number of bits sent per second. But baud rate is not number of bit per cent per second.
Number of
Baud rate is the number
signal
of
units per
signal.
second.
No, number of signals that are carrying those bits per second.
Okay, sir.
Okay, so bit rate is basically number of bits. Transmitting per second. Oh, sorry. Okay, and baud rate is number of signals carrying the bits per second. Okay, now suppose my bit rate is 4. This is my bit rate. Means that number of bits are transmitted per second is 0, 1, 1, 0, suppose. Okay, now suppose these bits are can be carried in 3 ways. 3 ways, not in 3 ways, general 3 ways. There may be in 5 ways. So the first case that I am considering like this. With this kind of signal. Or to draw like this. It should not be the proper one. I should draw like this, suppose. It should be like this. Because the minus 5 volt always we represent as 0 and plus 5 volt we represent as 1. So this is the encoding representation. It may be different also. Minus 5 volt can be represented as 1 and plus 5 volt may be represented as 0. But whatever encoding technique you are using, that you have to mention when you are transmitting from the sender to receiver. Or sometimes this kind of encoding technique also being used, that 0 voltage is considered as 0 and plus 5 voltage is considered as 1. Now here we are considering that minus 5 volt is considered as 0 and plus 5 voltage is considered as 1. Now this first signal is minus 5 voltage. That means it is representing what? 0 or 1? This minus 5 voltage here we are considering as 0, right? So it should be 0. Now, then the next time period, it is representing plus 5 voltage, right? Now this plus 5 voltage is representing what? 0 or 1?
1.
1. Very good. And the next time period, it should represent plus 5 voltage again, because the bit is 0, 1, 1, right? So it will represent again 1.
1.
Now in the next time period, it should represent plus 5 voltage or minus 5 voltage?
Minus 5.
Minus 5 voltage. Very good. So it should represent minus 5 voltage and the signal will be 0, 1, 1, 0. Up to this much is okay, Girija?
Yes, sir.
Okay. Now, if I consider this case, now my bit rate is 4 because 4 bits are passing in 1 second. Now what should be my baud rate? Baud rate definition is number of signals that are carrying those bits per second is called the baud rate. Now how many signals are carrying those bits? This is 1 signal, this is 2 signal, this is 3 signal and this is 4 signal. So number of signals is 4. Now here can I consider that baud rate is what? How much? Baud rate is
4.
4 signal per second.
4.
So here my bit rate and baud rate both are same. Clear?
Yes.
Okay. Now I am considering another case. Now I am considering another case. Suppose my bit rate is again 0110. Okay. Now I am, instead of representing as plus 5 voltage and minus 5 voltage, what I am doing, just a minute. Plus 5 voltage and minus 5 voltage, what I am doing, instead of one signal, I am using two signals to represent one bit. How? Means that 0 will be represented by, this one is my minus 5 voltage, this one is my plus 5 voltage. The first half of the time period, this is the entire time period T. First half of the time period, it will be represented as 0 minus 5 voltage. Next half period, it will be represented as plus 5 voltage. This one condition will be represented as 0. And in case of 1, it will be just opposite. That first half of the time period, it will be represented as plus 5 voltage, and next half of the time period, it will be represented as 0. Minus 5 voltage. Is this clear? Shall I repeat? Shall I repeat it again?
It's clear, sir.
Or it's clear now? Now tell me, this one is representing 0, this one is representing 1. Now next bit is 1. So how it should be represented? First half of the time period, it should be plus 5 voltage or minus 5 voltage?
Plus 5.
Plus 5. And the next half of the time period, it should be represented as minus 5. My next bit is 0, right? How it should be represented? First half of the time period, it should be represented as 0, and next half of the time period, it should be represented as, first half of the time period, it should be represented as minus 5 voltage, and next half of the time period, it should be represented as plus 5 voltage. Then I can say it is 0. Is this clear? This is another kind of representing your bits. Now, in this case, my bit rate is 4. Now, what is baud rate? Baud rate is number of signal carrying those bits is called baud rate. Now, tell me, how many signals are required to represent these 4 bits?
8.
8. Now, this is one signal, this is second signal, this is first signal, this is second signal, this is third signal, this is fourth signal, this is fifth signal. Sorry, 1, 2, 3, 4, 5, 6, 7, and then 8. Total 8 signals are required to represent the entire bit. So in this case, my baud rate is how much?
8.
My baud rate is 8. Now my baud rate is double than my bit rate. Okay. Now I am showing another case to you. Earlier we used to represent minus 5 voltage as 0 and plus 5 voltage as 1. Right now, what will you do that? We will divide the entire voltage level into 4 voltage level. One is minus 5 voltage, another is minus 2.5 voltage, another is plus 2.5 voltage, another is 5 voltage. Correct? Now, what will you do that? Plus 5 voltage will be represented as 1, 1. Plus 2.5 voltage will be represented, 2.5 voltage will be represented as 0, 1. Minus 2.5 volt will be represented as 1, 0, and minus 5 volt will be represented as 0, 0. plus 5 voltage 1 1, plus 2.5 voltage 1 0, minus 5 voltage 0 0. It depends upon you. Instead of this, you can take any other combination. Plus 5 voltage as 0 0, plus 2.5 voltage as 0 1, plus minus 2.5 voltage as 1 0. It's up to you what combination you will take. Okay. Now, if I consider this one, my bit rate is what? First, I am taking 0 1. Now, how the 0 1 should be represented over here? Irja, how the 0 1 should be represented? Through which voltage level?
Plus 5 to minus 5.
Plus 5, 0 plus 2.5 voltage. Yeah, plus 2.5 voltage, right? 0 1 should be represented. Look at here. 0 1 should be represented through plus 2.5 voltage. Yes or no?
Yes. Yes.
So I should represent 0 1. I should represent 0 1 as plus 2.5 voltage. So this is represented as 0 1. And next one is 1 0. 1 0 should be represented as
Minus 2.5.
oh, so I have done a mistake. So just a minute. 0 1 should be represented as plus 2.5 voltage, and 1 0 should be represented as minus 2.5 voltage, right?
Yes.
So here it is represented as 0 1. Next one is represented as 1 0. Now tell me, my bit rate is 4. Now here, how many signals are required to represent these 4 bits?
2 signals.
2 only. Now here my baud rate is. So bit rate and baud rate, it is not like that. It will be same every time. It depends upon you how you are representing your signal in terms of bits. It may be like that baud rate is greater than bit rate, or it may be like that baud rate is lower than bit rate. Now you tell me which one should be preferable.
Third.
Okay, that means bit rate, baud rate is lower than bit rate, because we are ultimately sending the signal. Now within one signal, if I can carry multiple number of bits, that case my transmission will be faster enough. Even in your 4G, 3G or Wi-Fi broadband network, your bit rate, baud rate is much lower than your bit rate, because your single signal level is carrying multiple number of bits. Here, to carry 2 bits by one signal, we are taking 4 voltage level. Now to carry 3 bits in one signal, how many voltage level we require? Last day Himjyoti has told. Here in a single voltage level, we are carrying 2 bits. Now, if I want to carry 3 bits in single voltage level, how many signal level will be required?
Sir, 8.
8 signal level will be required. Now, to carry 4 bits, we require 16 signal level. Yeah. So, it will be in the to the power of 4 level, signal level will be required. Now, nowadays, in the 4G network, we are carrying 128 bits in one signal. To get the faster network speed. Now is this clear? Bit rate and baud rate, everything?
Yes, sir.
Okay, thank you. Okay, so last day we are discussing about the sensor node communication. So even there are 2 kinds of sensor node communication is there. Either all the sensor nodes will be there and there will be a single sync, and all the sensor node will directly communicate with the single sync, and they will send the data to the sync. And in the sensor node, there is a concept of multiple number of source who will send your sensor data to a single sync. and sync will accumulate all the data of all the source, and then it will pass it to the server or whatever server is there for our analysis. Okay, and another option is that the sensor node, instead of directly communicating with the sync, which is the first case, they will send the data through multi-hop communication system. Means that they are not going to directly send it, they will send it via relay. Means that they will send it to their neighboring node will send to that neighboring node, that neighboring node will send to their neighboring node. In this way, it will come to the sync. Now, which one is preferable? Can you tell me? Because I have discussed it earlier. These questions may come in the exam. So this is called single hop communication. This is called single hop communication or single hop transmission. And the second option is called multi-hop transmission. You tell me which one is preferable. Shall I go for single hop or multi-hop? Today number of students is very less. I don't know why.
Sir, actually, you have given the time for to join this class from 9:30. We have been waiting from 9:30.
Why?
Sir, in the Google Classroom, you said you would take the class from 9:30 to 10:20.
Oh, 9:30. Sorry. Actual class timing is 10:30. I am sorry. It is my
So,
mistake.
actually, we've always
Because
been
in
waiting
your
from
timetable
9:30.
it is 10:30, na?
No, sir, it's 11:30.
Class timing.
Yes, sir. In class time it's
Okay. That
11:20,
case,
but
why you have not informed me that we are waiting?
sir, most of us are that you gave it by mistake, and everybody, some of us have left.
No. Please do one thing. Suppose I have given one timing. It's my mistake. I admit. Suppose that case, if you don't find me, please immediately either call me or send a WhatsApp message that we are waiting in the classroom.
Okay, sir.
This is my request. So actually, in hurry, I have written it 9:30 because the actual timing is actually 10:30. Okay. So
Yes,
if this kind of things happens, please notify me that we are waiting. You should not wait like this. Okay. Now tell me which one is preferable, single hop or multi hop? इसका तो आंसर तुम लोगों को पता है.
सर मल्टी हॉप होना चाहिए ना सर, क्योंकि सर
हाँ,
एक
multi
सिंक
hop.
में
Why
एक
multi
सिंक
hop?
में सर सारा नोड अगर एक ही सिंक में इंस्टेंट डेटा देता तो लोड ज्यादा होगा, पर यहाँ पे सर लोड बैलेंस हो सकता है सर अगर
Load is one constant, another is the energy.
एनर्जी
Because
सर
see here,
दूसरे सेंसर्स पे
all the
जब
nodes are not in the same distance. These nodes are in the further distance than these nodes. So those who are in the further distance, to transmit this data, they require more power. If they transmit directly with the more power, then their power dissipation will be higher than these nodes. That is why what they are doing, that with low power they are transmitting to their neighboring node, because the neighboring node is ultimately going to transmit their data also. So they are telling that, okay, when you will transmit your data to the sync node, please take my data also and submit it to the sync node. So multi-hop transmission is much more preferable than single hop transmission. Okay. So this one I think I have discussed. This one also I have discussed. Okay, now the next is the constraint of sensor node. So what are the constraint of sensor node? First is that it should be smaller in size, typically in the scale of cubic centimeter. So as small as possible. So why it is as small as possible? Because if the smaller in size, that case the power dissipation will be much less, and also it should be operated in an unattended manner in a highly dense area. Like I have told that if the size is higher, that if in the military zone or the war front, we cannot deploy all those nodes. Suppose, as I have given one example, that in Pakistan-Afghanistan border earlier, US Army used to spray a huge amount of pressure sensor node to identify the infiltration rate. Now, if the sensor node size is high enough or huge enough, that case it can be easily detectable, and people will avoid all those sensor node, and people will avoid to um, give a pressure on those sensor node while they are working. So it should be operated in an unattended manner in a highly dense area. Yes, and it should be low production cost also, because it's a high in number. We have to spray it, and another thing is that it is dispensable. Means after using this one, we have to throw it, because when the battery gets drained down, it is not possible to replace their battery. So we have to dispense it. And another is that it should be autonomous also. Autonomous means, so means that if any problem happens with those sensor node, there is no way to change those sensor node. So what we have to do, that we have to replace. So those sensor node, if the battery gets drained out, so they need to harvest the energy either by themselves, or they cannot ask for the help. So they should be self-reliant and self-sufficient. जो हम लोग का एक टर्म है ना, आत्मनिर्भर, so they should also be आत्मनिर्भर. Okay, and they should be adapted to the environment. Suppose if I put them in Mount Fujiyama also in Japan, so they try to get the actual data of the sensor node, of the data of the volcanic eruption. So at what time the volcanic eruption can happen. So they are putting the huge amount of sensor node on the crater of the volcano to get the actual data in terms of pressure or in terms of temperature, whatever it may be. Now, so it's an extreme weather condition over there inside the crater, right? So the sensor node has to be adaptive with that one. It is not like that it will get defunction or malfunction whenever we are putting those nodes inside the crater. Have you seen a movie Twister? ट्विस्टर बोल के एक मूवी था जो तुम्हारा हैरिकेन के ऊपर, ट्विस्टर by Mr. Seen that movie? Hello? Okay, so you can see that movie. Actually, the concept of that movie is that in US or in the Northern America region, there is a huge high occurrence of those hurricane. So to get the hurricane data, what they are doing, that they have the group of scientists, they have chased that hurricane, and after that they sent some sensor data. They spread some sensor data inside the hurricane. तो हरिकेन में क्या होता है, तुम्हारा जो सर्कुलरली जो मूव करता है विंड, so within that sensor nodes were also floating and moving within that hurricane, and they are connecting with those sensor nodes to get that hurricane is moving in which direction, what is the wind level, wind speed, what is the wind direction, and what is the pressure inside the hurricane. So all those data they are getting, so that they can take the evacuation process in a faster manner. So it's a movie where it has been screened 15 or 20 years back, but that time the wireless sensor node applications have been depicted in a very beautiful manner through this movie. So my request is, if you get time, you are seeing so many movies, you can watch this movie. This movie is very good. That time I was I think in a graduation level. But the concept, what they have thought that time, sensor node concept was not there. Still, the director has immaculate that idea, which has been now in reality right nowadays. So we can use the sensor node as this kind of application itself also. Okay, now in terms of applications, what are the applications we can do through the sensor node? Is the one is the temperature measurement, humidity level, lighting condition, or the air pressure, soil moisture level detection, noise level, vibration. Vibration means for the civil engineering purpose, this kind of vibration applications are very useful. What they do that I have told you, I think that in the inside the bridge, because if there is any damage is happening inside the bridge, so it is very difficult to identify. And suddenly one day the bridge will get collapsed and there will be a huge amount of casualty. Now, how to get out of it? So, what they have done that at the time of concretization, जब ढलाई होता है, so they put some piezoelectric sensors which can detect the vibration level. And even nowadays in the smart buildings also, they are putting this kind of piezoelectric sensors. Now this kind of piezoelectric sensors are actually, they are doing nothing. They are sending a small electrical signal. They are sending a small electrical signal like this. Okay, now inside this concrete, there is no air gap is there. There is no presence of air. So the whatever be the electric signal they will transmit, so it should be uniform in nature. And that electric signal is being captured by the sink every time. Now, if there is any crack happens, suppose this is the my concrete. Now inside this concrete, if there is any crack happens, then what will happen that whenever they are sending this signal, they will go inside this crack where there is a presence of air. Now whenever it will go through the air, then immediately the signal will get distorted. The signal will get distorted like this. Now when the sink receives the electrical signal, okay, there is a slight distortion, and the next day the distortion is increasing. Then they will come to know that there is a crack happens inside the bridge, and that crack is now increasing. Now immediately what they can do that they can take some immediate action to mitigate the process. Is this clear to you, students? Student, vibration application is clear to you?
Yes, sir.
Now, few cases that what are the complexity may arise in case of the sensor node. Suppose here different sensor nodes are there and it is numbered. You can see that 18, 15, 16. Can you see the numbers?
No, sir.
Numbers is not visible, na?
No, sir.
Okay, so okay. What I'm doing there, this is 14, this is 10, this is 8, this is 7, this is 13, 5, 11, 17, and these are different numbers up there. Okay, no issue. So this one is source, this one is source, and this one is sink. No, actually I have made a mistake. This one is source, this one is source, and this one is sink. You know what is source and sink? That means source will send the data to the sink. Now here the objective is little bit different. What is the objective? Is to detect any variable objects, any moving objects. Moving objects means in this case they may detect. Sorry, not this one. I should consider this one. 7, 13, 5, 11, 17. Okay. So in this case, any moving object. Suppose here one moving object is in front of the sensor 17 is that one human. So object is being detected, immediately. So this one is my source, not sink, and this is my sink. So it will be notified to the sink. Okay. Now source cannot send the data to the sink directly. They are sending the data through this direction. That's 17 to 11, 11 to 5, 5 to 13, 13 to 7, 7 to 8, 8 to 10, 10 to 14. 14 is the sink. Now the sink will get the data, and actually the sink is connected with the user. Now in the user, in its screen, it can detect that, okay, so the sensor node in front of sensor node 17, so there is a source, is there, that is called human. So suppose this application is being used in the video surveillance, where if any person is coming around the source, in front of the source, immediately it will be notified to the sink. Now in that case, from the source to sink, the direction should be there, but here it is in opposite direction. Means that from sink to source, the direction is there. Why? Because the sink is sending one query. Sink is sending one query. Now sink is actually sending the query to everybody, to its neighboring node. That is there. Have you seen any moving object detection? Now 16 will say that, okay, let me check with my neighboring node. Now 16 will check with its neighboring node 15. 15 will check its neighboring node 18. Now 18 does not have any neighboring node. 18 will say that, okay, there is no moving object. Similarly, 14 will check with its neighboring node 9. 9 will check with its neighboring node 6, and 6 will tell that, okay, there is no object is present. Similarly, 14 will check with its neighboring node 10. 10 will check with its neighboring node 8. 8 will check with its neighboring node 7. 7 will check with its neighboring node 13. 13 will check with its neighboring node 5. Then 11 and 17. Now 17 will tell you that, okay, one human movement is being detected. You got my point? Is this case study clearer to you, students?
Sir, can you repeat
Yes,
it again?
sir.
Again,
Yes, sir.
shall I explain?
Yes, sir.
Okay. Now, objective is that multiple numbers of nodes are being spread across the campus to detect the movement of any object. Okay. Now, for this, what I am doing, that sink is sending the information to its neighbor that if you find any object, please immediately notify me. So it is not like that sink is sending the data, sink is sending the request to all the nodes. Sink is sending the request to its neighboring node. Now what are the neighboring nodes of the sink? Sink is 14 actually. Its neighboring node is 16, 10 and 9. Now 16 will say that, okay, in my vicinity there is no movement. Let me check with my neighbor. His neighbor is 15. 15 will check with its neighbor 18. 18 will say that, okay, I don't have any further neighbor, and I can also did not find any object detection. So this side is ruled out. Now similarly, 14 will check with 10. 10 will say that, okay, I have to check with my neighbor. My neighbor is 8. 8 will check that, okay, I have to check with my neighbor. It is 7. 7 will check with its own neighbor. 13. 13 will check with its neighbor. 5. 5 will check with its neighbor. 11. 11 will check with its neighbor. 17. Now 17 will find out that, okay, there is a sink. So there is an object movement is there. So immediately it will notify it to 14. Now the case study is clear.
Yes, sir.
Okay. Now this is a simple case studies where everybody is checking with its neighbor, first checking in the first hand that whether there is any movement, whether there is any presence of any object or not. If there is no presence, then immediately it will notify to its neighbor whether any presence of its neighbor or not. Okay. Now this one will become a complex one if we consider the next one. But can you see the next slide? single source and multiple object detection? Yes. Next slide. Well, in source 17, instead of a single object, there are other objects are also there. There's the vehicle that is also moving, and the building that is not moving. Okay. Now 17 has multiple numbers of objects are there. So that case, the 17 has to detect first that okay, there is a movement of multiple number of objects. Now immediately they need to check that whether the movement of multiple number of objects are same or it's a different. That case, the 17 node number 17 have to analyze the data to identify through visual analysis technique that whether that detected object is a human or vehicle or animal or whatever it may be. And if the sensor node is so small that it does not have the visualization or object identification capability, that case it has to send all the data to the sink. Now sink has to analyze this data and have to come out with a decision. Now in that case, in the second case, that means if the sink has to analyze this one, that case it will delay the entire process. If the object is a dangerous thing, that means if I need to detect the object, if it is a terrorist attack, that case I need to take the decision immediately, right? So if it goes to source and source takes all the data and after that it think that it will take so many times that by this time so your purpose may not be served. So whenever we are putting few objects within our network, that entire things becomes complex. Means my sensor node limitation comes into picture. Means that I need to make my sensor node a little bit powerful. That is why the concept of edge computing and fog computing has come. What is edge or fog computing? It is basically a sensor node having the computational power also. Means that it is IoT sensor node. At the same time, I have the computational power inside it. Like right now, whatever surveillance camera you purchase, it has a small computational power, so that whatever video they are tracing, they are analyzing, making the first hand analysis also to try to identify the object, what kind of object it is. It is a vehicle or it is a human or whatever it may be. So is this clear? If it is a single source and single object, it is much more simpler. If it converts to single source and multiple object, it becomes a little bit complex. So in the next class, I will tell more about this kind of complexities, how the complexity will increase in case of wireless sensor network for getting our to reach our objective, to get our objective. Okay. Up to this much is clear to you?
Yes, sir.
Yes, sir.
So I will discuss the next two case studies, that is multiple source and single object detection, as well as multiple source and multiple object detection in the next class. So right now, I am ending up this session. Thank you for your participation.